Today I'm going to talk about a bacterial display system that we have developed at the department called Staphylococcal surface display. And I'm going to mainly talk about the applications where we use it for combinatorial protein engineering for selection of new affinity proteins, both antibodies but also other alternative scaffolds. This is then going to be about microbial display, and I guess all of you know that this field really started in the mid-80s with the development of phage display, and phage display is today still the most widely used technology of the display systems, and there are many reasons behind that, but it is a really well-working technology. It's really easy to use, and you don't need any really fancy equipment and expensive instruments and so on. And we are also using phage display quite a lot in the lab, but we are also then developing new display systems. And today there are a number of alternatives, actually, and we're going to hear about a few of them today at this short course. And some of these alternative display systems are then based on cell display. And you have, for example, E. coli display. You're going to hear more about that from Patrick Doherty, which was developed in the mid-90s. And then you have also yeast display, which is relatively established today for selection of antibody fragments, but also full-length antibodies. And that technology was developed by Dane Wittrup and co-workers in the late 90s. But we are then working with a gram-positive bacterial display system. And we're using a host called Staphylococcus carnosus. And before I get into the actual details of this technology and this host and show you the results from some of our projects, just going to say a few words about this organism because I guess that none of you have really heard about it before. So this Staphylococcus carnosus then, it's, as I said, a gram-positive bacterium, and it has actually mainly been used in the food industry in the past. So it's used as part of starter cultures for meat fermentation. So you put it in, for example, when you prepare sausages and stuff like that. And it's approximately 1 micrometer in diameter. And an important property for us is that this bacterium grows predominantly as singles. And you're going to see later on that we use a lot of flow cytometry in many of the applications. So this is a really important property for us. And this is in contrast then to many other Staphylococcal species that don't grow as singles. And it's also really non-pathogenic. It's, for example, protein A negative. It produces no toxins and has a really low extracellular proteolytic activity. And the genome was recently sequenced, and it was demonstrated that the Staphylococcus carnosus is actually relatively non-homologous to other pathogenic Staphylococca, for example, Staph aureus. So due then to this non-pathogenic behavior, but also is it sounding strange? It sounds a bit strange up here, no?